everyone. So today we're going to talk about 1-cyclopropanol and its structure and chemophysical properties. So let's start off by looking at the molecular formula, which is C5H10O, or 5 carbons, 10 hydrogens, and 1 oxygen. So the Cas number for this molecule is 765-42-4, and then there's 1 degree of unsaturation. So this degree of unsaturation tells us that there's either a ring or a pi bond in the molecule. Now, by looking at the name alone, we can see from cyclo that there is a ring in the molecule. So this tells us that 1, there's a ring, and 2, there are no double bonds or triple bonds in the molecule. So moving on to look at functional groups, there is an alcohol, which is just an OH group. The molecular weight is 86.13 grams per mole. The melting point is 31.4 degrees Celsius, and then the boiling point is 121 degrees Celsius. The physical state at 25 degrees Celsius, or room temperature, is liquid. And then over here, if we come and look at our molecule, which was drawn using ChemSketch, we can see this 3-membered carbon ring. So this is the ring that gives that 1 degree of unsaturation. So here is our 3 carbon, here's our 4 carbon, and then here is our 5 carbon, which makes this methyl group right here. And then up at the top, we can see our alcohol functional group. So let's take a little look at the bonding. So we can see from the structure that there are no double bonds. So that means that every bond is a sigma bond, which we can see here on the chart, there are 16 sigma bonds. Now, a lot of them are not visible because they aren't drawn out, but at each of these carbons here, there are 2 hydrogens, and then at this carbon 3 and carbon 4, there's another hydrogen. So I'm going to take my pen here, and I'm going to mark where those hydrogens would be. So there would be 1 here, there would be 1 here off that 3 carbon, there would be 2 coming off these corner carbons, let's erase that. Let's redraw that line. So there we have all of those hydrogens drawn out. So we also have these bonds here, which are not drawn, but we know that carbon is bonded singly to each of those 3 hydrogens, and the same goes for that oxygen molecule. Now, carbon only wants 4 bonds, so each carbon is bonded to 4 different atoms. Oxygen only wants 2, so that's why it's only bonded to this 1 carbon and this 1 hydrogen. And hydrogen only wants 1 bond. So if we go over here back to the chart and we look at hybridization, we see that all 5 carbons are sp3. This just means that every carbon is only singly bonded. It doesn't have any double bonds or any triple bonds. Double bonds would be sp2 and triple would be sp, which is why these are both 0. So if we go over here to the CH classification, we see that there is 1 methyl or CH3 group, which is right here. And then if we go to CH2 or methane, we see that there are 2 of these, which are these 2 carbons here at the corner of the ring. And then CH, there's also 2. This is called methine. And there's 1 here, and there's 1 here at those 3 and 4 carbons. And then there's no carbon that is not bonded to hydrogen, so we have 0. So now that we have a better idea of what the planar structure looks like, let's go and look at the 3D model. Okay, so now we're going to look at doing the 3D model. So here we have carbon, which has 4 bonds. So we need to get 5 of those. So 1, 2, 3, 4, and then 5. So now we need to get hydrogen, which has one single bond. We need to know those 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So this is oxygen, which can make 2 bonds. And then lastly, we have these little gray pieces here, which will be used to make the single bonds in the ring. So we're going to start by making that 3-membered ring. So we're going to attach this little gray piece here to the side of a carbon. We're going to attach the second carbon here, and then we're going to take the second gray piece and attach it to that second carbon. And then we're going to take this third carbon and attach it in the middle and make that 3-membered ring. So then next we're going to take the fourth carbon and attach it there, and then the fifth carbon will be attached on the side here to make that methyl group. So let's put oxygen on that other corner so that we can make our alcohol group with this hydrogen here. And then next we're going to take 3 hydrogens and put them on that fifth carbon so we can make our methyl group. And then we're going to take these hydrogens and put them on the corner of the ring, and we're going to make all of those carbons satisfied. And we're going to flip the molecule over so that we can put these hydrogens in the corner here, and then put our last hydrogen on that fourth carbon. So right here you can see where we're going to attach that last hydrogen. So there you go. There's our 3D molecule, 1-cyclopropylethanol. So here you can see that first carbon, the second carbon, the third carbon here, and if we shift the molecule a little in the middle, you can see that fourth carbon. Here we have our alcohol group, and then lastly we have that fifth carbon, which makes up this methyl group here. So you can rotate this molecule and see the back of carbon 3 in the front where that hydrogen attaches. And then you can rotate it again to see the back of that fourth carbon where the hydrogen is attached from the back. So there you have it. There is your 3D molecule using Snatoms.